Hello everyone, and now we're on to chapter 4, chapter on carbohydrates. We're going to begin our study of 3 different macronutrients. Each macronutrient has their own chapter. In this one, chapter 4, we're going to study what a carbohydrate is, what's its role in the body. Again, we're going to go through the process of digestion, but this time more specific to carbohydrates. And then what happens when we consume too much. Let's start by describing what is a carbohydrate. Well, a carbohydrate is one of 3 macronutrients. It's found in vegetables, bread, flour, rice, for example. A carbohydrate is a molecule made up of 3 different types of atoms: carbon, hydrogen, and oxygen. It literally means hydrated carbon, hydrated as in water, made of hydrogen and oxygen, and carbon for carbo. You'll often see me writing CHO for carbohydrate. It's just the abbreviation. So we obtain carbohydrates mostly from plant foods such as fruits and vegetables and grains. Plants make the most abundant form of carbohydrate, it's called glucose, through a process called photosynthesis. During photosynthesis, the green pigment of plants called chlorophyll absorbs sunlight, which provides the energy needed to fuel the manufacturing of glucose. Water is absorbed from the earth by the roots of the plants and combines with the carbon dioxide present in the leaves to produce the carbohydrate glucose. Plants continually store glucose and use it to support their own growth. Then, when we eat the plants, our bodies digest, absorb, and store the glucose. Specifically, there will be 6 atoms of carbon, 12 atoms of hydrogen, and 6 atoms of oxygen in one molecule of glucose. There are 2 different types of carbohydrates: the simple carbohydrates and the complex carbohydrates. Look at the words below, saccharides. When you see saccharides, you'll know I'm talking about glucose. Mono means 1 molecule of glucose. Di means 2 molecules of glucose. So if you have a monosaccharide or a disaccharide, which is 2 molecules attached together by a high energy bond, you have what we call a simple carbohydrate. The body is good at absorbing simple carbohydrates. Complex carbohydrates, poly meaning many, saccharides meaning sugars, are long molecules containing several sugars, which the body cannot absorb because it's too big of a molecule. It needs to be broken down through the process of digestion. Now, in terms of simple carbohydrates, there are 6 that you need to be familiar with. Monosaccharides, the single sugars, are called either glucose, fructose, or galactose. The disaccharides, the 2 molecules attached together, are either called maltose, sucrose, or lactose. Notice that OSE at the end of the word. Again, we're talking about sugar. Now, in terms of monosaccharides, the 3 different monosaccharides, the fructose, the glucose, and the galactose, are different because they have different configurations. They all have 6 atoms of carbon, 12 atoms of hydrogen, and 6 atoms of oxygen, but they're all organized in different geometrical forms. They also have different characteristics. For example, fructose is known as the fruit sugar. It's converted to glucose in the liver once it's absorbed by the body. Sources are fruit, honey, high fructose corn syrup. Galactose is the milk sugar. It's never found alone. It's always attached to a glucose molecule to form lactose. It's also converted to glucose in the liver once it's absorbed by the body. Glucose is the sugar that the body uses. It's fuel for the brain. It's also the sugar that travels through the bloodstream. If you put 2 monosaccharides together, you obtain a disaccharide. For example, if you put a glucose with a galactose molecule, you'll end up with a lactose molecule, also called the milk sugar. If you take 2 glucose molecules and bind them together, you end up with maltose. Maltose is not found in food naturally, but can bound itself to other molecules and is a product of fermentation. If you bind a glucose to a fructose molecule, you'll end up with sucrose. Sucrose is the sweetest of them all. It's found in sugarcane, sugar beets, and honey. It's also known as table sugar, so the white sugar you typically put in your coffee. Putting 2 saccharides together requires bonding them together. There are 2 types of bond. Alpha bonds. The alpha bonds are easily broken by human digestive enzymes, which means if you have 2 molecules held together with alpha bonds, they can easily be broken down during digestion. But there's also beta bonds. Beta bonds hold two sugar molecules together, but they're indigestible by the human enzymes. That means the molecule itself will not get broken down and will have to be excreted from the body. If you were to attach more than two molecules of glucose together, you'd end up with complex carbohydrates, or polysaccharides. Polysaccharides can be put into two different categories, the digestible polysaccharides and the indigestible polysaccharides. The digestible polysaccharides are long chains of glucose that are held together with alpha bonds, which means your body's enzymes can break down the bonds to separate the individual glucose molecule. The indigestible polysaccharides are held together with beta bonds, which means your body cannot break down the bonds and the molecule will be excreted from the body as is. The indigestible polysaccharides can be divided into two types of fiber. There's insoluble fiber and soluble fiber. The apple here is a great example. The meat of the apple, pectin, is an example of soluble fiber. The skin, cellulose, are an example of insoluble fiber. It's a bit tougher, a bit more structural. The insoluble fiber increases fecal bulk matter. So it increases the bulk of the feces and decreases its time as it goes through the intestinal tract. Soluble fiber, on the other hand, delays the gastric emptying, which means it slows the gastric emptying, allowing more time for the bacterial flora to feed off of the fiber. It also attaches to cholesterol and helps excrete the cholesterol. It also slows glucose absorption, which we'll see a bit later on, that that's quite important. So the bacterial flora will feed off the soluble fiber. Each of the molecule will actually yield 2 kilocalories of energy. That energy, though, does not get used by the body. It gets used as a fuel source for the bacterial cells themselves. So in order for the bacteria to stay happy and healthy in your large intestine, it needs to feed off of soluble fiber. It can, though, create gas, as you can imagine what will happen to that gas. Okay, so we talked about the different types of carbohydrate and what the molecule looks like. Just remember, there can be simple or complex carbohydrates. Simple would just be one simple glucose molecule, or disaccharides where you would attach a few glucose molecules together. Complex carbohydrates would be long chains of glucose attached together with either alpha bonds in the case of digestible carbohydrates or beta bonds in the case of indigestible carbohydrates.